Okay, so we're going to talk about slope this unit. Does anybody know what slope is? Yeah. Say that again.
I don't.
Did I not hand out enough? Sorry. Thought I did. Anybody know what slope is? Anybody have an idea? If you had to describe slope, what do you think you would say? Yeah. Something going up or down. I agree. Like a hill or a ramp, right? You go skiing on the ski slopes because it's slanted, okay? So when we talk about slope, we're going to talk about that, but we're also going to talk about unit rates. We're going to talk about what independent and dependent variables are. Okay, so the first problem here says the subway car travels 2.5 miles in 5 minutes. Find the speed of the subway car in, and it got cut off, it's supposed to say miles per hour. Okay, so if I want to find miles per hour, what goes first? Remember, our label kind of tells us what order to put this in. I want to put miles on the top because it's saying miles per hour. Okay, so when we talk about unit rates, miles per hour. Miles goes on top, hours goes on the bottom. Now that means miles is what's called our dependent variable, and hours is our independent variable. Okay? What is a dependent variable? Have you talked about dependent variables in science class maybe? No, not at all? Maybe not this year because science changed. A dependent variable just means it depends on other factors. Okay, it depends on other factors. Independent variable, a variable that can stand alone. It's independent. It can be by itself. It doesn't need any other information with it. Okay? So when I say the hours is independent, time just keeps moving on its own, right? The miles depend on how long you've been driving. Would you agree with that? Okay. So if I want to find miles per hour, this says 2.5 miles in 5 minutes. 2.5 miles in 5 minutes. I know that's not miles per hour, right? That's 2.5 miles in 5 minutes. How many minutes are in an hour? 60. So 5 times what would give us 60? Yeah, 12. So I'm going to go to 60 minutes, and I'm going to times by 12. Grab your calculators out, because you're going to need them a lot today. Do 2.5 times 12. If you don't have a calculator, go grab one. I got 30. 2.5 times 12 is 30. So 30 miles in 60 minutes, or 30 miles per hour. Agree with that? Right? Okay, so that's our unit rate. Well, unit rate is the same as slope. Okay, so if we're making a graph, our slope would be 30. Now, in our minds, we might not know what that means yet. It will make sense as we keep going here. Okay, finding a rate from a table. Okay, this is moving down on your page. So sometimes we go across, now we're going down. The table shows the amount of money you can raise by walking for a charity. Okay, so if you walk 2 miles, you're going to earn $24. 4 miles, $48. 6 miles, $72. 8 miles, $96. We're going to find our unit rate. These are our two variables, distance and money. Which one do you think is dependent and which is independent? Does the dollars depend on the miles or the miles depend on the dollars? What do you think? Lexi? Yeah. How much money you make, right, depends on how far you walk. Would you agree with that? So when we say dependent and independent, the money is dependent on the distance. The distance is independent of the miles. Okay, when we look at a table, I'm going to give you a clue here that if the table is set up as our X and our Y, right? A table is always X and Y as our variables. The X is always our independent variable. The Y is always our dependent variable. So if we're not sure, it's always X is independent, Y is dependent, no matter what. Okay? So now I want to find the unit rate. The dependent variable goes on top. I want to look at the dependent variable. I'm looking at this table and I'm looking how much is the money changing? How much does the money keep going up by, Abby? 24, right? Goes up by 24, up 24, up 24. So the change in money is 24. How much does the distance keep changing by? Where does that keep changing by? Lexi? 2. So we have 24 over 2, and then we're going to simplify that. I want it to be a unit rate, so I'm going to divide by whatever's on the bottom. 24 divided by 2 and 2 divided by 2, that's 12 over 1. What does that mean? It's a whole number, it's 12, but what does it mean in context of this problem? What's the unit rate? 12 what? What's the label on the top? What's the dependent and what's the independent? Abby? Yeah. $12 per mile. Okay, if you were walking for this charity, you would be earning $12 every mile you walked. Does that make sense? Okay, let's try another one that's a table. Okay, this table shows the distance that the International Space Station travels while orbiting Earth. Find the speed in miles per second. Okay, here's my table. We have our X and our Y. Which one's the independent variable and which one's the dependent variable? Which one's independent and which one's dependent? Look at the last table. What did we say? Which one's always the independent? Which one's always the dependent? Casey.
The distance, the time in seconds.
Absolutely, and the distance would then be the dependent. Okay, so the distance, the miles, depends on the seconds. So how far the space station travels depends on how long it's been traveling. That seems to make sense, right? That makes sense in kind of any miles per hour, miles per second, doesn't matter. How long I'm driving in my car, or the number of miles I go depends on how long I've been driving in my car. Okay? So we need to find the change in distance. Dependent goes first over independent. What is this number changing by every time? What is it going up by, Lexi? Okay, we're always adding 14.4. Our dependent variable, 14.4. What's the change in time? How many seconds is it going up by, Casey? 3. This keeps going up by 3. And now we need to simplify. When we simplify it, you guys, you're always just going to divide by whatever's on the bottom. I want it to be a unit rate. I want this to be 1, so I'm going to divide by 3. I also have to divide the top by 3. 14.4 divided by 3 is 4.8. What does that mean in this problem? 4.8 what? What's our labels on this? Abby? 4.8 miles per second. That's fast. Have you ever watched the sky in the summer and see that moving star? Okay, it's usually a satellite. Actually, just recently you were able to see the International Space Station moving in the sky. Okay? When you can see that star that looks like it's moving, it's a satellite, and it is moving really fast. 4.8 miles per second. Just think about that. 4.8 miles. That's like from, if you started at the freeway in Melrose and went to Freeport in 1 second. Okay? That's how fast those satellites or the International Space Station is moving, and that's why you can see it moving. It doesn't look like it's moving that fast, but it's so far away from you that it really is moving extremely fast. Okay? All right, flip the page to page, we're on page 2, okay? So now we're gonna look at finding rate from a graph. So we've looked at a table, now we're gonna look at a graph, okay? The graph shows the distance that sound travels through water. Find the speed of the sound in kilometers per second, okay? We still need to understand what our independent and dependent variables are. And when we look at a graph, remember I said we have y and x. Which ones always are dependent and which ones are independent? Y is always dependent. So this is our dependent variable. This is our independent variable. Okay? The distance that the sound travels depends on how long it's been traveling. Again, that makes sense. Okay? So if I want to find the speed of sound in kilometers per second, I'm going to choose a point on the line. This one, I'm going to choose the 0.23. And this point shows me that the sound travels 3 kilometers in 2 seconds. Notice how I read the point backwards? Right? It was the 0.23, but I read it backwards. Any ideas why I read it backwards? When we read a point and we're talking about independent and dependent, the dependent always comes first. Okay, so 3 kilometers in 2 seconds. Because the dependent variable is our kilometers, and the independent variable is our seconds. Okay, you're going to have to be able to identify independent and dependent on your homework. I'm going to make this so that I can see. Okay, maybe I can't. Okay. Oh, there we go. So let's find the speed. If it travels 3 kilometers in 2 seconds, let's simplify that. What would that be? Find the unit rate. I'm going to divide by 2. That's 1.5 kilometers in 1 second. The speed is 1.5 kilometers per second. If we used a different point to find the speed, do you think our answer is going to change? If I use this 0.46 instead, do you think my answer is going to be different? Let's try it. What does the 0.46 mean? 4 stands for, that's our x, that's seconds. The 6 is kilometers. Abby, did you have? Okay, that's right. So if we did kilometers per second, we'd have 6 over 4, right? And simplify that. Find the unit rate, divide by 4. What's 6 divided by 4, Abby? 1.5. It's still 1.5 kilometers per second. How do you think we might know by looking at the graph that no matter what point I pick on the graph, the speed's going to be the same? And it's a straight line, okay? As long as all of our points are in a perfectly straight line, that means it's constant and they're the same. Okay, flip the page And let's talk about sound through air. Okay, this graph shows the distance that sound travels through air. So we just talked about how fast sound travels through water. Now we're going to talk about it traveling through air. So we want to find the speed of sound in kilometers per second. Is it going to matter which point I pick on the line? Absolutely not. We can pick any point. So, I don't know, let's choose this one. So the point 4, 1.4 shows that sound travels 1.4 kilometers in 4 seconds. Right? It took 4 seconds to travel 1.4 kilometers. What's the independent variable and what's the dependent? Abby. Okay, just like the last one. Our y variable is the dependent. Our x variable is the independent. That's always going to be true. So we're going to find the speed. The distance traveled was 1.4. The time was 4 seconds. So we use our calculator to find the unit rate. 4 divided by 4 is 1. 1.4 divided by 4 is 0.35. The speed is 0.35 kilometers per second. Does it travel faster in water or air? Where does sound travel faster? In air, this is air, it was 0.35. Remember, water was 1.5 kilometers per second. Which is faster? Brayden. Water. It travels much faster in water than air. Okay, if I put that on the graph, we could see it from the graph because that graph would have looked like, I'm going to go back to that point, 2, 3, 2, 3. This is air, this is water. Can you see from the graph that it travels faster in water? It's steeper, right? What happens when you ski down a steeper hill? You go faster. So the steeper that line is, the faster it is, the bigger the slope. Okay? All right, so we're going to go to Canvas. And I'm going to help you get started on your homework. Huh? That's okay. Okay, so we're going to Wednesday, March 23rd. It says homework, unit rates and slope. Okay, so the way this looks says there are some problems that say for each table below, identify the independent and dependent variables, then find the unit rate. Okay? Use all lowercase letters when entering the independent and dependent variables. Okay, so type everything lowercase, please. Otherwise, it'll mark it wrong. And spelling counts. You guys, the words are right here. I hope you can spell them right. Okay? When entering the unit rate, you do not need to enter a label. You're just going to enter the answer. Okay? So I'm going to help you out with the first one. When we look at a table, which is our independent and which is our dependent? Abby. The top is always the independent on the table, and the bottom is the dependent because it always goes X, Y. And X is always going to be our independent, Y is going to be our dependent. Okay? So our independent variable, we're going to put days. Our dependent variable, you're going to put miles. That makes sense to everybody so far? Then it asks you to find the unit rate. When we find the unit rate, it flips. When you write unit rate, it always becomes dependent over independent. So we have to look at this. How much is it changing by? Abby? 30 over, how much does this change by? 2. And then we simplify it. Divide by 2, divide by 2. It's 15 over 1. Okay, so you are going to type in as your unit rate either 15 or 15 over 1. Done. Does that make sense on how to do those problems? Okay, I'm going to skip ahead a little bit because there are 4 more problems like that, and then there are 5 problems with graphs. Okay, so for number 6, I'm going to skip ahead to number 6. For each graph below, identify the independent and the dependent, and then find the unit rate. When we look at a graph, same thing happens, right? This is our X and this is our Y. This is our independent. This is our dependent. So independent variable is games. Dependent is points. When we find the unit rate, we're going to put dependent over independent. Okay? Does it matter which point I pick on the graph? Absolutely not. Okay, you can pick any point on the graph. Just make sure it's on a corner. I'm going to pick this one. I like that one because automatically my one number is 1. So how many dependent, how many points per game? Abby? 20. It's 20 over 1. There's your unit rate. Now, if you were to pick this point, would it still be the same thing? Absolutely, because that would be 80 over 4, which would simplify to 20 over 1. 20 points, 20 points per game. Okay? All right, your job is to finish that assignment. Okay, and I'm okay if you move and work with each other and talk with each other. So go ahead and do that.